multiply with variables. Susan uses the following equation to determine how much heat therapy to prescribe depending upon the patient's level of inquiry, which you can see right here. In this equation, P stands for the patient's pain rating, X indicates the length of time that the patient has been in pain, N indicates the number of therapy treatments, and we're going to multiply and reduce this fraction to simplify the equation. So the reason we give you this information about what the letter means is to remind you that the variables in the equations are just placeholders for real numbers. The physical therapist will get the real numbers from assessing and working with the patient. For example, the patient may share that his or her pain rating is a 5, and then the physical therapist would remove the P from the equation and put in the number 5 instead. And the reason that we would like to have the equations with variables is because each patient will provide different information. Therefore, it is helpful to have the formula set up so the physical therapist only needs to put the numbers in the right places to easily find the answer. That being said, this equation is not really complicated the way that it is currently written. So let's work to multiply and reduce it so that we have a much more easy way to look at it. So let us begin by multiplying. So remember, when we multiply fractions, we multiply the numerators together and the denominators together. So we get 20npx. And then on the bottom we have 10x squared. So now let us expand what this looks like. So we can now go 20, which is really 2 times 5 times n times p times x. And then below we have the 10, so that becomes 2 times 5 times x times x. So let us now cross out anything that we have on the top and on the bottom. So we have a 2 on the top and a 2 on the bottom. We'll cross these out. We have a 5 and another 5. So we can cross these out. We have an x here and an x here. So let's cross these out. Now we don't have any more factors that are in common, so let us now write this out. So we have 2np over x. So this is our reduced fraction. So let's go ahead and look at another example. Example 2. Sina is a medical researcher studying the effectiveness of cold therapy. She has been recording the rate of reduction of inflammation over a period of time in multiple patients. She uses the following equation to help her determine how much cold therapy is effective for certain injuries. We're going to multiply and reduce this fraction. Now for this equation, we will use the fractions as two separate fractions, but we're going to expand on the exponents. So here we have 4 times x over 3 multiplied by 9y over 8 times x. So this time though, we're going to see that this 4 here and this 8 share a common factor of 4. So we'll just divide by 4 on the top and the bottom here. So 4 divided by 4 is really 1. So we're just going to go put a 1 right there. Or you can also just put it more like right here if you want to expand it. But either way, but you know it's right there. So now we look at the 8. We're going to cross this out. Now 8 divided by 4 is equal to 2. And so we're going to write a 2 right here, as we now have a 2 there and not an 8. Now we can see that we have an x here and an x here. And so instead of multiplying out to then divide by each other to make it 1, we'll just do it right now. So x and x can be crossed out. Now we also notice that this 3 and this 9 right here share a common factor of 3. So 3 divided by 3 here becomes 1. Now 9 divided by 3 becomes 3. So this kind of looks a little messy, but we can see that we have a 1 here from this, and we only have an x. So we're going to write out the x. From the second term that we multiply, we have a 3, which we'll put in front, and a y. Then on the bottom, we go look, we have a 1 here, and then just a 2 there. So we'll just leave it as 2. So now we have our reduced fraction, because we've already done all the reducing before we even multiplied. So this is our final solution. So as a reminder, we use variables as placeholders, and then we write